Guys, don't forget when you're joining, have your KDISD number in your name, first name, last name, and your KDISD number in your name. So make sure you fix that in your usernames. All right, give me a quick second, guys, and we'll get started in about a minute or two. We get started in about a minute or two, guys. Until then, just get your questions ready so we can go over it. Okay, let's go ahead and get started. All right, just like always, you have a question, use a little raise hand emoji thing. I'll call on you in the order that I'll raise your hand in, and I'll go over that problem. I don't really have anything set for the final exam, just regular tutorials. Any questions y'all want me to go over on the final exam review or anything like that? Shalish, go ahead.
Hi, could you go over number 9 on the final exam review?
Yeah, okay. This one, right?
Yes.
All right, and Ashika, please put your first name, last name, and your KDIC name in your name. All right. So what the domain of f of x is from -7 to 8, and its range is -4 to 7. And we're asked which is the range of g of x if g of x is these transformations on f of x. So what's basically saying is that you have a graph f of x, and we do these transformations on f of x to get to g of x. And whenever you do a transformation on a function, you're going to do it to its domain and range too, right? Like for instance, this -2 means I vertically stretched it by 2, right? So my range also increased by a factor of 2, and that negative tells me that, well, we also vertically reflect it, and at the same time, you're going to reflect it on your range as well. So I want to figure out what is the range of g of x. What's the range of g of x given that these transformations on f of x? So what I'm going to do is I'm just going to do the vertical transformations on the range, because the range is my y's. So my transformations will be that -2 and that -5. So what I'm going to do is multiply the range by -2y minus 5. And that's going to give me my new range. And that's what I'm going to get for my range of g of x, because you took your y's, you vertically stretched it by 2, you vertically reflected it, then you moved it down by 5. So that's what I'm going to do. I'll multiply -4 by -2 to get -8, minus 5 to get -13, and you keep the parentheses with it. And I'll do the same for -2 gives you +8, sorry. -2 times -4 is +8, minus 5 gives you a 3. Then I'll do the same thing with the 7. I'll take the 7 and plug it in as well. -2 times 7 is -14, minus 5 is -19. That had a bracket, and now you just rearrange it from least to greatest. So -19, comma 3. And that's your answer. I only cared for the range, so that's what I'm going to get. That's all I'm going to look for. Does that make sense?
Yeah, I think I plugged in the range into the entire equation instead of just what would be affected. So I put the range for x and then did something really random.
Yeah, so that's kind of what's happening because of the it's a vertical stretch and all that stuff on f of x itself. We don't know what g of x actually is, so that's why you can't really do that.
Yeah. Okay, thank you.
No problem. Rude, to be honest, I didn't expect so many people to show up today. Yesterday was only like a handful of people, so it would have been a little easier. To be honest with you, I'm not 100% sure how we can do today, except we're just kind of busy today. If you want to come tomorrow morning, you can, and you can bring a friend or 2 to them in class or in line class before school. And I'm fine with that if you need your hours. Does that sound fine? Sorry about that. I didn't expect you to be so popular, so busy. All right, Malachi, go ahead.
Could you go over number 4?
Number 4. We went over that one yesterday. Sounds a little confusing. Okay. Yeah, this one. So using function notation, write a formula for the height of a cone in terms of its volume, given its height measures 3 root pi times that of its radius. All right, so there's a few things going on. The first thing is that we're going to use we're using function notation to write a formula for the height of a cone in terms of its volume. So when it says write a formula for the height of a cone, that means write it as h equals whatever it is. When it says in terms of the volume, it's saying, well, I want h in terms of v. So I want h of v equals ... whatever it's going to be. But to get that, figure out what the height of a cone will be in terms of its volume, well, we don't really know what that is. That's not really normal to know. What we're going to do instead is we're going to start with the formula for the volume of a cone, which is pi r squared times height divided by 3. Pi r squared, the base, times height, all divided by 3. And I'm going to solve this out for h, because I want to write it in terms of v. So I'm going to take this function right here, solve it for h equals, and that's going to be my formula for the height of a cone in terms of its volume. So I'll multiply by 3 to move that over. So 3v equals pi r squared times height, divide by pi r squared to get 3v divided by pi r squared, and that all equals my height. So this right here, that's the formula for the height of a cone in terms of its volume, my h of v. Right, that's what it means when I say in terms of, it means the variable in that equation should be in terms of that variable. So in this case, the variable should be v for volume. But I'm also told that the height measures 3 root pi times that of its radius. Or in other words, h equals 3 square root of pi times r, or 3r root pi. That's what I'm told. So I know that's what h equals, but the problem is I don't want to plug in h into here and get rid of h because I want it as h equals. But what I don't want is I don't want this r in these equations. So what I'm going to do is I'm going to solve this green equation for r equals to be able to plug it into the other equation and get rid of that r. So I can divide both sides by 3 pi to get h divided by 3 root pi equals r. Does that make sense so far? Why I'm solving for r and I'm going to plug that in?
Yeah.
All right, perfect. Because r is another variable. I don't want it in terms of r. I want it in terms of v. So I want to get rid of that r if I can. All right, so I know what r equals now. R equals height divided by 3 root pi. But what I want to plug in is I want to plug in r squared. So I'm going to square this r to get h squared all over 9 pi, and that equals r squared. So I know what r squared is, so now I can plug that into the formula and finally get rid of r and have my final answer. So let's go back to red. H of v will equal 3v divided by pi times that h squared divided by 9 pi. And then from here, I can see that this pi and this pi cancel each other out and have h of v equals 3v divided by, well, not pi, but r squared, or sorry, h squared divided by 9. And that is the same thing as 3v divided by h squared over 9. So what I'm really doing is dividing a term by a fraction. So I can rewrite this as 3v multiplied by h squared divided by 9 flipped. And this all equals h of equals h. We'll leave it as h right now. So what I'm going to do is kind of just simplify it down. 3v times 9 gives me 27v. H squared, I'm going to move it to the other side by multiplying both sides by an h squared to get h cubed. Cube root both sides to get rid of the cube to end up getting 3 cube root of v equals h. So it's like a lot of arithmetic going on there. Because the big thing here is to know that you start with the equation for the volume of a cone, set that equal to h equals, because that's what we want, and then plug in what our h equals. The height measures 3 r root pi. Solve that for r, plug that back in, simplify it all the way down. Does that make sense?
Yeah, thank you.
No problem. Any other questions about this problem before we move on?
Mr. Aziz?
Yes, go ahead.
So if this problem is on the final exam or something like it is on the final exam, is it going to be a multiple choice or a free response? Because if it's multiple choice, then I have a higher chance of getting it right.
I can't tell you that.
Okay, no problem.
But if it is on there, I think chances are it probably will be multiple choice actually. If it's on there, chances are it's multiple choice.
And just to double check, there's 36 multiple choice and 7 free response, right?
Let me double check for you actually. It's in my hands. It is, yeah, 36 free response. Well, 1, 2, 3, 4, really 5 free response. So 36 multiple choice, 5 free response, and 2 graphic, which I guess kind of is free response, but 2 of those 7 free responses are graphic.
And it's gonna be on Scantron, or like it's gonna be like the cumulative where we write out the letters?
You're gonna write out the letters and we'll grade it that way. So no Scantron. All right. Any other questions about this problem before we move on? All right, Anand, go ahead. I don't know if you're talking, but I can't hear you. Anand, do you have a problem? Oh, and Braxton, can you please put your KDIC number in your name, please? All right, just go ahead and type in the problem you want me to do, Anand, in the chat if your mic isn't working, and we'll go over it. All right, I guess we'll just go on to Alvin while Anand's getting his problem ready. Alvin, go ahead. What problem you want me to do?
Oh, do you mind going over number 22 on this final review, please?
22? Sure.
Yes, please.
Oh, this one. Okay. Yeah, we did this yesterday. This one, the warning I'll say for this problem is that make sure everything is in the same unit. Because this one I was doing it yesterday and it threw me off because this is in terms of feet and then the rate is in terms of inches. So really quick, just make sure you guys always pay attention to the units. Don't do what I did and kind of overlook that because that will change the whole answer to the problem. All right, anyway, we're told Abe is climbing a tree, and when he is 15 feet up, he notices a snake 7 feet above him slithering down the tree. He's terrified of snakes and freezes. The snake continues down to the ground at a rate of 3 inches a second, as if unaware of his presence. We're gonna write an absolute value function that models the vertical distance the snake is from Abe with respect to time. So what that's basically saying is that we're gonna write a absolute value equation. What we're gonna do is we're gonna write the absolute value equation that kind of models what's happening. So remember the absolute value, it's really just kind of like the distance formula, because it's kind of where the distance comes from. It comes from the absolute value because that's kind of almost like another name for it. So what I like to do is I always like to draw pictures. It's gonna make your life a lot easier. So this whole thing, just label the axes first. This will be t for time, and y is d for distance. So this whole thing starts when the snake is 15 feet away from Abe. So at time 0, the snake is 15 feet away from Abe. And then it goes at a constant rate of 1/4 foot a second. So the rate we'll put to the side right here, r is 1/4 foot per second. Kind of convert that 3 inches a second to feet. And that's my rate. And then when he gets to this point right here, he's at a distance of 0 away from, sorry, not 0 there. At some time, he's a distance of 0 away from Abe. We don't know what that distance is. We're gonna solve for that. And then after that, he starts going further away from Abe until he gets to, I actually don't know how far it is. Oh no, sorry, it's not 15 here, it's 7, because the snake is 7 feet away from him, not 15. Sorry about that. So the snake is 7 feet away from him, sorry about that. And he's going at 1/4 a foot a second till he gets to Abe, and then he keeps going 1 feet away from him until he gets to a height of 15, but that part isn't that important. It doesn't really help me get my equation. What I care about is this HK right there. So what I know is that he's going at 1/4 a second. So I need to figure out, well, when my y is 0, what is my x going to be? I know I have a 0.07 right here. So my absolute value formula is going to be f of x equals my rate of 1/4. We got that from the r, times the absolute value of x minus some h that we don't know, plus my k value of 0. That kind of just goes away. And what I'm going to do is I'm going to plug in the 0.07 and figure it out. You also could kind of just use that line is a decreasing slope to figure it out as well. That works too. But we can do it this way as well. So plug in 0.7, 7 equals.
A quick question. How did you know that it was decreasing?
I'm sorry?
How did you know that like it's decreasing? Like,
Oh,
how do we know that this graph right here is not upside down?
Oh, it's a good question because it's distance, right? So this whole thing starts when the snake is 7 feet away from Abe, right? So we start at this point right here, right?
Mm-hmm.
So at a time of 0, the snake, the y-axis is distance. So at a time of 0, the snake is 7 feet away. And then the snake is going towards Abe and then going further away from him, right? It's kind of going towards him and then it keeps going down away from Abe afterwards, right? So Abe is actually right at this vertex. This vertex is where Abe is. So because the snake is slithering down, he's slithering down the tree towards Abe. Does that kind of make sense? So over time, after Abe sees the snake 7 feet away from him, that snake is getting closer and closer to him. So we're decreasing in y's as the time increases. Does that make sense, Alvin?
Okay, yeah, it does.
Yeah, so that's kind of how you know it's gonna look this way. So 7 equals 1/4. My x is 0 minus h plus 0. 0 minus h is negative h. Absolute value of negative h is just going to give me h times by 4. 28 equals h. So it takes 28 seconds for that snake to get to him, and that's what my h value is going to be. It's going to be 28 So he's plugged that back into my formula right here. So we get f of x equals 1/4 x minus 28 plus 0, but it's kind of irrelevant. Does that kind of make sense?
Yeah.
Any other questions about this problem? And I'll go back to your problem in a second. Any other questions about this problem before we move on? You can just unmute yourself and ask.
Just a quick question. The way you'll take the slope of an absolute value function is from the right arm or the right side of the function, right?
Yeah, because that's kind of this. See the slope right here? This is actually a
Yeah.
negative 1/4.
Yeah.
And then from here is positive 1/4. So yeah, you're right. Is that for me, like I drew the graph and I saw, well, I'm positive, right? I'm opening up, so I know I'm gonna be positive, so I didn't have to really look at the right side. You kind of just figured out yourself. But yeah, you're 100% right. The slope of the absolute values from the right arm, yeah, exactly.
Okay, thank you.
No problem. All right, let's go back to number 9 really quick. Anand, number 9, how do you get f of x plus 2 equals y? Since we usually see f of x as y. Number 9. What do you mean f of x plus 2 equals y? So we use f of x as y. What do you mean by that? I'm not sure I understand what you mean by that, Anand.
So can you hear me?
Yeah, I can hear you now.
All right, so my question is, since we usually see f of x is as y, how did you conclude that f of x plus 2 equals y? Since like, like I don't understand like how you got like, oh, f of x plus 2 equals y.
What do you mean f of x plus 2 equals y? Where did I write that?
Like you converted the equation from -2 f of x plus 2, and then you converted that to 2y.
I didn't
Right.
convert that. No, I took a transformation rule. The transformation rule is bx plus h, ay plus k. So my a is -2,
Mhm.
my k is -5. So that's where I got -2y minus 5 from. So I didn't, it's just more just this is a transformation that -2 f of x plus 2 minus 5 is a transformation of the graph f of x. So I know that this transformation rule, and I guess the bx plus h will be just x minus 2. This transformation rule right here transforms your x and y points into your transformed x and y points. So that's how I figured out the -2y minus 5.
Oh, okay. Thank you.
Yeah, so, or in other words, I have a vertical stretch of -2 and a shift down by -5. So you multiply your y's by -2, then subtract 5, which is what I did here to get your new y's. So that's kind of what happened.
Okay, yeah, thank you. That makes sense.
No problem. Arjun, go ahead. I can barely hear you now.
I had a question.
It's really hard. Your voice is really muffled. It might be easier if you just kind of put in the chat.
For 41.
41? Okay.
Like, I think I went over it yesterday, but like in your thing yesterday, but I think the answer on the key was different.
It's really hard. Sorry, it's really hard to hear you, but I'm hearing something like we went over it yesterday, but it's still kind of hard to understand. Is that what you're saying? All right, you wanted to go over it again? Answer on key was different. So, yeah, it's 0. That's what we said yesterday, wasn't it? Let's go over it again. So, how many x-intercepts is a quadratic of the form y equals ax squared minus bx minus 6 have if 24a is less than -b squared? So remember, if I'm asking how many x-intercepts, that's another way to say, well, how many solutions do you have? So we're using b squared minus 4ac minus discriminant. So if I figure out my b squared minus 4ac of this graph right here, my b squared is -b. -b squared is still going to be b squared minus 4 times my a value of a and my c value of -6. And I get b squared plus 24a, right? And so what I'm going to do now is I'm going to take this inequality that they give me, and I'm going to make it put everything on the right side and on the same side. because b squared and 4ac should be on the same side. So if I add the b squared over, I get b squared plus 24a is less than 0. B squared plus 24a is less than 0. So if I have b squared minus plus 24a is less than 0, that matches this. So that tells me my discriminant is less than 0, right? If my discriminant is less than 0, I have 0 real solutions. Or in other words, I have 0 x-intercepts. I have 2 non-real solutions, but non-real solutions aren't x-intercepts, they're not real. So that's why you have 0 real solutions, and I'm pretty sure that's what it says on the key. Yeah, that's what the key says. Key says 0. Does that make sense, Arjun? Perfect. All right, Alvin's good. Can you give him the question?
Do you mind going over number 25 on the final review, please?
25? Sure.
Mr. Aziz, well, 1 second, sorry to interrupt. Could you go back to that slide? I just had a question about that problem.
Sure.
Yeah, so on the second step for the green writing, like the second where you said negative b squared is the same as b squared.
Yes.
For the green step, how come it's negative b squared is b squared for the green side but not for the red side?
Well, the red side, all they did was they subtracted the b squared to the right side, and they kind of messed with it. Because this y equals ax squared minus bx minus 6, this is the discriminant right here. When I fixed it, it is a discriminant of the y equals. It's the same discriminant that I have. All they did was they kind of just, well, they took this discriminant right here and said, well, if I subtract b squared to the other side, I get this. They just kind of moved it over the other side of the inequality. That's all they did.
Okay, okay.
Yeah, they kind of just play with the answer and say, well, this is what we have. Well, how many x-intercepts do you have? It's kind of just, that's kind of what they did with it.
Okay.
Makes sense? Go ahead.
And because you take it to, okay, and the green side is equal. Okay, got it. Thank
The
you.
green side was figuring out what my discriminant actually is, because I have this inequality, but I don't actually, I have this inequality, but I don't actually know what that inequality is or how it's related to the graph. So what I did is I figured out my discriminant first, what it actually is. Then I took the red side and I solved it to equal the discriminant. And then from there, I can see, well, what does the inequality tell me? And it told me that b squared plus 24a, which is my discriminant, is less than 0. So I have 0 real solution.
I got it. Thank you so much.
Perfect. No problem. All right, 25 you said, right, Alvin?
Yes, please.
25, find all values of k that allow that nonsense to have at least one solution for x. So it says have at least one solution for x. So that means if I isolate the absolute value, get absolute value of x plus 3 equals 6 minus k all divided by 2. So for it to have at least one solution, it needs to be 6 minus k over 2 has to be greater than or equal to 0. Okay. So I just want to make sure I have the right answer before I start explaining it to you. Yep, perfect. All right. So you see this right here? We have this absolute value right here, right? This 2x plus 3 plus k is equal to 6, right? This is what I have. And to figure out if I have at least one solution, what that says is that the absolute value of x plus some h, whatever's inside of it, has to be greater than or equal to 0, right? Or, no, sorry. Let me back up real quick. It has at least one solution. What it's telling me is that what the absolute value equals has to be equal to greater than or equal to 0. So if I solve out this absolute value right here, I can subtract k over to get 2x plus 3 equals 6 minus k. Divide by 2 to get absolute value of x plus 3 is equal to 6 minus k all divided by 2, right? Because anytime you're solving absolute values, you always have the absolute value kind of isolated. And I want to know, well, when does this absolute value have at least one solution? And to have at least one solution, this right side right here has to be equal to or greater than 0. Because if you kind of treat this like two different graphs, like let's say I have this graph right here. So if I graph the absolute value of x plus 3, I have right here, right? For it to have at least one solution, this right here, the 6 minus k divided by 2, has to be greater than or equal to 0. Because if it's greater than or equal to 0, this term, because this is a real number, will be aligned either right here or anything above it. And like always gives me two solutions, at least one solution, right? So when 6 minus k divided by 2 is equal to 0, you have one solution, that's the vertex. But when it's greater than 0, that means you have more than one solution. Does that part make sense so far?
So you said that when it's equal to 0, you have one solution. When it's greater than 0, you have two solutions. And then when it's less than 0, you have no solution.
Exactly, because 6 minus k divided by 2, that is some number, some real number, right? So when you have this equation like y equals 6 minus k all divided by 2, and that's a real number, you have a horizontal line, right? So your horizontal line will cross the absolute value function one time when it's 0, and multiple times or two times when it's greater than 0, like I have on these green lines on the graph. Does that make sense? So that's why we. Sorry, go ahead.
Yeah, I had a question about this problem. So you're getting the greater than 0, like kind of like the same rules as discriminant, or it's dependent upon the x plus 3?
The discriminant is really only, it's not really, it's only for the quadratic. Discriminant is only for the quadratic equation. It's not for anything else. So I would not relate this to the quadratic or the discriminant.
Then I didn't quite understand how you knew it has to be greater than or equal to 0.
All right. So you see how you got the 6 minus k divided by 2?
Yeah.
You got this part right here.
Yeah.
So this 6 minus k divided by 2, that's a real number, right?
Oh, yeah.
It's a real number. So what I have right here is I have an absolute value equaling to some number.
Okay.
So I'm basically saying, well, what this absolute value graph right here in blue, how many solutions do you have when it equals some number? Like let's say 2. It equals 2. Let's say 2 is right here. It has two solutions. If 6 minus k equals, I don't know, like 4, it'll be right here. You have two solutions. When 6 minus k over 2 equals 0, on this line right here, I have one solution.
Oh, so it's like a horizontal line. Okay.
Yeah, because it's a horizontal line. But then 6 minus k divided by 2 equals, let's say, -1. I'm right here now. I have no solution.
Oh, okay.
Does that make sense?
Yeah.
So that's what I'm saying. Well, I can see here that my 6 minus k divided by 2, if it's when it's greater than or equal to 0, I have at least one solution. So I can solve this out. I multiply both sides by 2. 0 times 2 is just 0. So I've just 6 minus k is greater than or equal to 0. Add the k over. 6 has to be greater than or equal to k. And I can see that because when I plug in 6 into this formula right here, I get 0. And every k value less than 6 will give me a positive number greater than 0. Like 5 will give me 1/2 and so on and so forth. So that's what my answer is going to be. K has to be less than or equal to 6. And that is what the key says. Perfect. Does that make sense, Alvin?
You set the x plus 3, the absolute value of x plus 3 to 0, right?
I wouldn't say you set it equal to 0. It's more you isolate it, and then you get this term right here, right? 6 minus k divided by 2.
Yeah.
And then this is a number, right? It's basically kind of like saying, well, I have an absolute value of x plus 3, and that equals, let's say, 7, right? When it's 7, I have an absolute value like this, right? This is 1, 2, 3. And when it equals 7, when we saw the graphically, remember we do each side like it's its own graph. So I graph y equals x plus 3, which I did right here. Then I also graph y equals 7, right? That'll be, let's say, right here. And where it crosses, those are your two solutions, right? So now I just kind of look at this graph, the absolute value that I drew, and I say, well, when is it going to have at least one solution? We'll have it at 0 right here and everything above it. So you're not setting the absolute value equal to 0. you're more just seeing, well, when the absolute value equals some number, what does that number have to be so that I'll have at least one solution? Does that make sense?
So you're saying that the number to the right always has to be greater than 0?
I don't like saying it like always, because in math you'll never have, you'll almost never see the words always used, because it really depends what the problem's asking, right? That's why stuff like this, I always like to draw pictures and see, well, what am I really looking for, and going from there, right? So what I did is I isolated the absolute value to get x plus 3 equal, absolute value of x plus 3 equals 6 minus k divided by 2. And this 6 minus k divided by 2, that's a real number. It's like, it can be like 7 or 8 or 9 or 10 or negative 24. It doesn't matter. It can be any real number, right? So I guess another way to think about it is the absolute value will have solutions when? When will the absolute value have at least one solution? Or,
Okay.
or another way is like, when does an absolute value have no solutions? An absolute value has no solutions when it's negative, right? So it has no solutions when it's negative. So I need 6 minus k divided by 2 to be positive. I need to be greater than or equal to 0. Because when it's greater than or equal to 0, that's when you have at least one solution.
Okay.
Does that make sense?
Mm-hmm.
All right. Any other questions about this problem? I know it can be a little confusing. Any other questions about this problem before we move on? Jeremy, do you have a question about this problem, or just a question in general? Or a question you want me to do?
I want to know how we do number 26.
Okay, I didn't know if you had a question on this problem. We're going to go to Arjun first, and then we'll go to 26. All right, Arjun, go ahead. On 26, what does it mean by right inequality? All right, so I guess both of you want to do number 26, so we'll just go on to 26. All right, so for number 26, it says right inequality whose solutions matches the graph shown. All right, so in other words, I need to write an inequality where this is the solution, right? So to figure this out, what you want to do, or kind of a way to kind of see it, is it's an absolute value. So I know that what's going to happen is I'm going to have some kind of graph that kind of goes like this, and my solution is when I'm above this line. So what I want to do is I want to figure out, well, what is this vertex? This isn't drawn to scale, so we're going to figure it out itself, but the vertex is the midpoint between these intercepts. That's how you kind of want to do it. So what we're going to do is we're going to add 5 with negative 3, which is negative 2. No, sorry, it's positive 2 divided by 2 gives you 1. So actually kind of almost is drawn to scale. So this right here has a y value, or as an x value of 1. So the midpoint between the two numbers is going to be your, what's it called? Your h, sorry, your h, the h of the vertex. So the midpoint between your two intercepts right here, 5 and negative 3, that's your h value. So I know my h is 1, and now to figure out my k value, that's going to be the distance from the vertex, or this 1, to each of those points. And this is 4, and that's 4 as well. So what this is saying is that, well, I want the absolute value of x minus my midpoint of 1 to be greater than or equal to, because that's where my lines are, they're greater than the line, greater or, than the distance 4. And that's going to be your answer. Oh, no arguments. That's not that's a shoot, kind of a loophole, I guess, but it kind of is an inequalities. But I think what we were really wanted to know is an inequality of an absolute value. This is a better way. I think that was a little bit a better way to word that problem, Arjun. Write an inequality of an absolute value function that has this solution. And Jeremy, does this problem make sense? How we did that?
Yes. Sorry.
All right. And Arjun, does that make sense? What I said? How come the solution is just when the function? It's not when it's positive. It's greater than 4. Because like 2 is a positive number, but it's not a solution. The solution is, and also solutions are from -3 to -infinity. We have a lot of negative solutions as well. So the solution, this is the inequality. This is the answer. This is the answer to the problem. The solution is just when the function is positive. It's not when it's just positive, it's when it's on this line. Like when it's greater than negative, when it's less than -3. So when x is less than or equal to -3, those are solutions. And when x is greater than or equal to 5. These are where all your solution sets are going to be. Make sense? All right, great. All right. Who has a question next? Do you want me to go over? If anyone has a question, just go ahead and raise your hand and we can go over it. Shalish, go ahead.
Can you go over question 60, please?
60. Am I saying your name right? Shalish?
It's Shailesh.
Shailesh?
Yeah, it's okay.
Sorry. Sorry?
Yeah, question 60.
60, got it. Okay. And then Anon will go to you next. All right. A farmer wants to construct 3 adjacent equal-sized pens, of which will use his barn as one of its sides. Each pen will share a side with at least one other pen. There's 240 feet of fence to use. What is the maximum area you can fence in this manner? We're going to set a quadratic model, use and solve the problem. Okay. So for this problem here, what we're going to do is we're going to we're going to need to make 2 different equations. One for all the fencing that he has to use, like what we have to cover with fencing, and the other one an area formula, so we can figure out how to maximize. So everything that's being used for fencing is right here. Everything in blue is everything he's using fencing. So what I need to do is I need to label all those lines, because all those things added together gives me my 240 feet of fencing. So I can label each little line as X, and I can label this big one as Y. So 4X plus Y has to equal 240, because that's all the fencing that's being used, right, for all that part right there. And at the same time, I want the area of that little pen thing to be as big as possible, because if I'm using 240 feet of fencing, I want to get the most bang out of my fencing, right? I want to be able to maximize how much area I can contain. So the area of this pen is X times Y. So area equals X times Y. And to solve this out, what I'm going to do is I'm going to solve this first equation for either X or Y. It doesn't matter which one you want to do, and plug it into the other equation. Because when you do that, you end up getting a quadratic. And with quadratics, you know what your maximum point is going to be, because that's going to be your vertex. So I'm going to solve this first one for Y because it just seems a little easier. So I get Y equals 240 minus 4X. And I'll take it and plug it into my area. So A will equal X times 240 minus 4X. Distribute out the X to get 240X minus 4X squared. And this area is actually A of X. And what I'm going to do is I'm going to complete the square for it. So I'm going to rearrange it and factor out a -4 to get X squared minus 60X. And we can divide 60 by 2. This gives you 30. Squared gives you positive 900. And then from the outside, we get 900 times -4 is negative 3600. So subtract negative 3600, or we get -4x minus 30 all squared plus 3600. So the area that is maximized is 3600. This is going to be your maximized area, and it happens when your X value is 30. Does that make sense? Shailesh, I think you said right, how to say it that way?
Yes, thank you.
Any other questions about this problem? If you have a question about this problem, just unmute yourself and ask, or we're going to go on to the next person.
Mr. Aziz, can you just hang on for a second? I just want to take a photo.
Sure.
I got it. Thank you.
Perfect. All right. Also, guys, if y'all want, at the end of the session, I can just save this whole thing as a PDF, and I can just post it. Oh, excuse me, post it in the chat if it's easier for you guys. All right, Anand, go ahead. What's your question? Number 42. Sure. All right. So 2 plus I cubed times 2 minus I raised to the 5th power. We're going to solve this out. So the cool thing about this problem, or I guess not kind of cool, but kind of like the easy part of this problem, or the trick to this problem, is that 2 plus I and 2 minus I, they're the factor form. They're conjugates of each other. Is a better way to say it. Actually, they're conjugates of each other. So when you multiply them together, the i's kind of cancel out. So what I want to do is I want to rewrite this in a way so that I can multiply 2 plus I and 2 minus I with each other, because it's going to make it a whole lot easier to solve. So I can rewrite this as 2 plus I cubed times 2 minus I cubed times 2 minus I squared. This is the exact same thing. And after that, I can isolate these two together and take out this exponent of 3 to get 2 plus I times 2 minus I all cubed times 2 minus I squared. So this is the kind of trick of the problem. Because at this point, 2 plus I and 2 minus I, it's a difference of squares. So you multiply them together, what you get is 4 minus I squared all cubed, 2 minus I squared. I squared is -1, so you have 4 minus -1 all cubed, 2 minus I squared, which we should actually FOIL out now. But 4 minus -1 is 5. We have 5 cubed times 2 minus I squared. 2 minus I squared, that's the perfect square trinomial. So what we get is a squared, which is 4, minus 2 times -I. So we get minus 4I. Right, 2 times 4, yeah, 4I, and then plus b squared I squared, just like that. So 5 cubed is 125. I squared is the same as -1, so we get 3 minus 4I. Then distribute out that 125. Okay. We get, what was that, 375, 250, 375, minus 250, 500I. And that's how you do this problem. The trick is to kind of realize that the difference of squares are the conjugates of each other, and put them in a way so I can multiply 2 plus I and 2 minus I together. So you can simplify this down as much as possible. And when you did, we end up getting a difference of squares, which gives you 5. You can cube that, and 2 minus I is a perfect square trinomial, so that foils out pretty nicely as well. Does that make sense? Perfect. All right, any other questions about this problem before we move on to the next one? If not, Tanish, go ahead.
Can we do 66?
66. Okay. Ours of the functional solution only has one solution. X squared minus 10x plus 2y equals -14. 3x minus 1 equals r. Okay, so for this one, what I want to do is I want to simplify this. Actually, before that, anytime I see only one solution, I see a quadratic, that tells me I'm gonna use my discriminant. So what I'm gonna do is I'm gonna figure out a way to plug in this r into the other equation, or to kind of combine these two equations into one, so I can use my discriminant to figure out that one. So I can solve this 3x minus y equals r to get 3x minus r equals y. Just add the y over, subtract the 3. And I can plug this y into the other equation to get x squared minus 10x plus 2 times 3x minus r equals -14. From there, x squared, ugly x, minus 10x plus 6x minus 2r equals negative 14. Start adding like terms. I'll add the 14 over 2. X squared, 10x, this is going to be a 10. 10x and 6x is positive 4x. And I have negative 2r plus 14. That all equals 0. And the reason you want it equal to 0 is because the discriminant only works when the quadratic is set equal to 0. So r is, it doesn't say here, but r is supposed to be a real number. So I need to figure out, well, if I find a discriminant, what is my, what's it called? What's my b value going to be? Or what's my r value going to be? So my a value here, or should we write this one more time to make it a little nicer? X squared plus 4x. I can factor out a negative to get negative 2r minus 14 equals 0. So my a is 1, my b is 4, and my c is negative. I guess it doesn't really matter. It's negative 2r plus 4. Actually, it's kind of nice, so I don't think it's point to do this. Like this. My c is negative 2r plus 14. So a is 1, b is 4, c is negative 2r plus 14. I plug that into my discriminant. So b squared gives me 16 minus 4 times my a value of 1 times my c value of negative 2r plus 14. So 16 minus, well, this kind of goes away. So we can distribute out that negative 4. Let's do that actually. So we get positive 8r and minus, what is it, 1656? 56. And I want this to be only one solution. I want this all to be equal to 0. One solution means your discriminant needs to be equal to 0. Is everyone with me so far? Does it make sense? All right. So from here, just solve for r.
One second, sorry to interrupt. Isn't the b value negative 4? Because 10x plus 6s equals negative 4x.
Well, I cannot. Yes, you are 100% right. It should be negative 4. Thanks for pointing that out. But that's not going to change too much. Let's go over here. So it's now going to be. This is ridiculous. B squared minus 4ac. All right, it doesn't change anything because b just gets squared anyway. Actually, yeah, doesn't really change anything. B squared is 16 minus 4 times a, which is 1, times c is negative 2r plus 14. 16 plus 8r minus 56 has to be equal to 0 because I want my discriminant to have only one answer. I want it to be equal to 0. And we can combine those together to get negative 40 plus 8r equals 0. Add 40 over. 8r equals 40. R equals 5. So that's kind of how you do it. R is supposed to be a real term, so you plug in the other equation to the first one, get your own equation, and then from there you want to figure out what you're looking for. I want to know when my discriminant will equal 0 because that gives you one solution. You solve that out and you get R equals 5.
Okay, I get it. You use the discriminant. But suppose there wasn't an x squared. Then what would you do?
If it wasn't an x squared, it's really going to depend on the problem. Like in that case, you can still, if it's x squared, might be easier. You just plug into the other one and solve that equation out for x, or solve it for r actually. And I guess if you don't have an x, you can't really do anything with it. It's just the quadratic is pretty special in that you have a quadratic formula which has a discriminant. That's why you have a problem like this for quadratic. You don't see in like module 1 or 2 for absolute value. What did you guys solve absolute value?
Okay.
But it just depends. You got everything with the first step. What step is that, Arjun? Is it plugging? Is it this part right here, plugging this in and getting this right here? The 3x minus r. Okay. So this 3x minus y equals r. I solved this for y. So I add y over to get 3x equals r plus y. Subtract the r over to get 3x minus r equals y. And then this is what y equals. So I can plug into the first one because those y's are the same. Make sense? Perfect. Let me go ahead and erase this. All right. Any other questions about this problem before we move on? If not, Arjun, you have a problem? Oh, you said yes as in you have a problem. You have a question about that problem, or yes as you got what I said. 59. Okay. So Carrie's on top of Fisher Tower, which is 900 feet tall. Mark is sitting on top of him on the tower, 576 feet tall, and Harrison is laying in the bed of his Ford truck, watching from below. Carrie drops a marble, and Mark waits to drop his until after Carrie gives a marble passes him, because they're right next to each other. We don't know how long Mark waits until after Carrie's marble drops, but he does wait until after it passes him. Harrison is watching as both marbles hit the ground, and he notices the time between impacts is 5.5 seconds. How long does it take Carrie's marble to pass Mark, and how long does Mark wait after Carrie's marble passes him to drop his marble? So it's kind of two questions here, and we're going to kind of solve it all up. So Carrie, she's on a tower that is 900 feet tall. So we'll see C for Carrie, and she's dropping a marble down that tower. Down that tower. And then there's Mark. He's right here at a tower that's 576 feet tall. And that's his tower. And he's dropping a marble on top of that tower as well. And what we need to know is we're trying to figure out how long does it take Carrie's marble to pass Mark, and also how long does Mark wait after Carrie's marble passes him that he drops his. And we also know that it takes 5.5 seconds between the impact between Carrie's marble and Mark's. So for Carrie's marble, she drops her marble, and we don't know how long it's going to take, but what we do know is that 5.5 seconds after it hits the ground, she's kind of just waiting for Mark to hit the ground. And then after that, we have Mark. He's going to wait a certain amount of time, we don't know how long, until he drops his marble, and then it hits the ground. And what we're going to do is we have kind of like a few things we need to solve for. And we can solve all this out with the d of t equals 16 t squared formula. The distance in terms of time equals 16 times t squared, time squared. So I'm going to figure out how long does it take Carrie's marble to actually hit the floor. So from here to here, how long does that take? So the distance of that's 900, so I can plug that in to get, well, 900 equals 16t squared. I want to know what t is, so I'll solve by t by dividing by 16 to get 900 divided by 16 equals t squared. Square root both sides, so 900 squared is 30, 16 squared is 4, and that equals t. So this takes 30 over 4 seconds, which is what, 7.5 seconds? So it takes Carrie's marble 7.5 seconds for it to hit the floor. And then she's waiting 5.5 seconds after that. After that, I can also figure out how long does it take Mark's marble to hit the floor after he drops it. So for his, it's a height of 576, and that's going to equal 16 times t squared. We'll do the same thing, divide by 16. 576 divided by 16 equals t squared. Take the square root of both, and I think 576, the square root of 576 is 24. I'm going to double check that though. I'm really sure on that. Yep, it's 24. So 24 over 4, sorry. Yeah, it'll be from 645 to 705. Perfect. Just make sure you bring your friend. I don't think anyone's going to show up, but yeah, 645 to 705. All right, so take the square root of both sides. 576, the square root of 576 is 24. The square root of 16 is 4. The square root of t squared is obviously t. So t equals 6. So it takes Mark's marble 6 seconds to hit the floor. So this is supposed to be 6 right here. But I can see that if I add up all of Carrie's time, I get 13. So this whole thing right here is 13 seconds. So that means Mark's whole time has to be 13 as well. So that tells me that Mark has to wait 7 seconds until he drops his marble. And we're also asked how long does it take for Carrie's marble to pass Mark. So I want to know how long does it take for Carrie's marble to go from 900 to the height of 576, which is equal to Mark. Or how long does it take to drop 900 minus 576? So 900 minus 576, let's figure that out. 324. So I want to know, well, how long does it take for the distance to fall 324 feet? So 324 has to equal 16t squared. Divide both sides by 16. 324 divided by 16 equals t squared. 324 squared, or square root of 324 is 18. So we take the square root of both sides. We get 18 divided by 4 is t. 4t is what, 4.5 seconds. So what that says is Mark, it takes 4.5 seconds for Carrie's marble to pass Mark. And Mark waits 7.5 seconds until, or 7 seconds until he drops his marble. So it's kind of like a lot of playing around with stuff, making tables and timelines and all that nonsense to kind of piece together. But doing this problem, I think the answer key might have worded something wrong. Yeah, because that second part is it's worded a little weird. But that's how you solve this. Does it make sense, Arjun?
Could you go over how you got the 324 again?
Sorry, say again? Go over what?
How you got the 324.
Oh, the 324. So one of these problems, that purple part, is figuring out how long does it take for Carrie's marble to pass Mark? Because that's that first question. How long does it take for Carrie's marble to pass Mark? Well, Mark is 576 feet tall, right? No, he's not that tall, but he's on a tower that's that tall, right? And Carrie's on a tower that's 900 feet tall. So when
Oh, so they're just subtracted.
Exactly. 900 minus 576 is 324. That's how far the marble has to drop for it to pass.
Okay.
And how long does Mark wait? So Mark waits 7 seconds after Carrie drops her marble before he drops his. Does that make sense, Arjun? Is this purple part? Sorry, this part right here, these timetables. This dotted part is when the marble is not dropping. So when Carrie drops his marble, Mark is waiting 7 seconds after Carrie drops hers, until he drops his. Make sense? Great. Any other questions about this problem before we move on? All right, Tanish, go ahead.
So this might be a bit too much, but factoring was one of my weaker units. So like there wasn't any factoring notes, but could you show like the different types of factoring there are, like completing the square, grouping? Those are the only two I can think of the top of my head.
Well, I'm not gonna go over each one because I can't remember each one or examples of each one off the top of my head. But I think this review actually has factoring review in the bottom at the end. But there is, this factoring at the end of this review.
Yeah, I noticed that, but like, could you at least tell me the types
Names?
of like the names of them so I
Sure.
can just,
So there's difference of squares. There's difference of squares, perfect square trinomials. I think there's factor by grouping. And there's just regular factoring out with the X chart and all that kind of stuff. Is that? I think that's it. This GCF, that's the big one. Always look for GCF first, and then start factoring. This should always be first. So we're gonna try to move this. So always look for GCF first. There's these two factoring patterns, difference of squares and perfect square trinomials, and then there's factor by grouping.
okay. And you'll post a PDF of all of these in the chat so I can download it.
Yeah, I'll post the PDF in the chat. Just make sure you stay till after the whole thing's over, so I can just put it in the chat.
Okay, got it. Thank you.
All right, no problem. All right, Arjun, go ahead. Arjun, 38. Okay. An outfielder from a height of 7 feet throws a baseball to the second baseman. An outfielder from a height of 7 feet throws a baseball to the second baseman. Once the way the ball reaches the height of 25 feet after traveling 90 feet towards. Okay, so stuff like this. Let's draw a picture. An outfielder from a height of 7 feet. So he's, let's say right here, he's at some 7 feet because he's 7 feet tall. Throws a baseball to the second baseman 165 feet away. So it's like 165 at some height y we don't know. The ball reaches a maximum height of 25 feet after traveling 90 feet towards the second baseman. So he reaches a maximum height. So let's say this is the maximum. A maximum height of 25. After traveling 90 feet towards the second baseman. So after 90 feet of it going, it reaches a height of 25. How off the ground is the baseball when it reaches the second baseman? So I want to figure out what this y is going to be. And if it'll be possible for the guy to actually catch it. Like, will it actually make sense for this guy to catch it? So we're gonna write a formula for this. So y, or f of x, will equal some a value that I don't know, times x minus 90 squared plus 25. And I got this part because this is my vertex. When it says the word maximum, like it reaches a maximum height, that's going to be your vertex, right? You're throwing a ball, the ball kind of goes parabolically, like you throw a ball, it goes up, it starts kind of curving back down. It's a parabolic shape, and its maximum height is your vertex, it's your HK. So all I need to do is I need to figure out, well, what's my A value going to be? And I cannot use the vertex because also on 37 key was the 80 mean. I'll go over that in a second. Let's finish this problem first. All right, so here I need to solve A. I cannot use the vertex because the vertex will just cancel everything out. What I need to use instead is a 0, 7. So 7 equals some A value of 0 minus 90 squared plus 25. So 7 equals A times negative 90 squared. That is negative 810. Right, 9 squared is 81. No, negative that. So from here, solve for A, divide by 20, subtract 25 over. 7 minus 25 is negative 18. So I have negative 18 equals negative 81, or positive, so it'd be positive. You can't have a negative, right? Yes. Positive 8100 A. Divided by 8100, get negative 18 divided by 8100 equals A. And 8100. This reduces down to negative 1 over 450. So what I did, I figured out my quadratic formula by using my vertex. Yeah, negative 90 squared would be positive. I just kind of messed up there. Then I solve this out for A, and I get negative 18 over 8100, and that reduces down to negative 140, negative 1 over 4. So my formula is f of x equals negative 1 over 450, x minus my h of whatever that is, 90, all squared, plus 25. Fix this. 9. Is everyone with me so far? All right, and then from here, all I need to do is I need to figure out what this y value is going to be, and that happens when x is 165. So that's what we're going to do. We're going to plug in 165 in for x, or in other words, we're figuring out what f of 165 is. That equals negative 1 over 450, 165 minus 90 squared plus 25. So that gives me negative 1 over 450. 165 minus 90 is 75. 75 squared. I have no clue what that is. 5,000 625 plus 25. Divide that by negative 450. And 565 divided by 450 is 12 and a half. Negative, so we get negative 12.5 plus 25, or finally f of 165 equals positive 12.5. Or in other words, the ball will be 12 and a half feet above the guy in second base after it's thrown. And will that make sense? Will this guy realistically be able to catch it? No, I don't think there's anyone who can jump up that high. He's like 6 feet tall, 7 feet tall. I don't think he's jumping 5 feet, 5.5 feet to be able to catch the ball. So in this case, is it realistic? Probably not, because it doesn't really make sense for the guy to be able to jump that high to get. Does that make sense, Arjun? C, great. Any other questions about this problem? I know this one can be a little confusing. Any questions about this problem? Just unmute yourself and ask if you have one, or we're just gonna move on. All right, so 37, you said, Arjun, what does the 80 mean? Let's see. So 80 looks like it's gonna be the combined height of the cliff and the cannon. So when you add the height of the cliff and the height of the cannon, you should get 80. That's what it means. All right, Anand, go ahead. Anand, do you have a question?
Yeah, could you go over number 56?
All right, so I want to know, I define k values so that 2 times x minus 3 squared minus k equals 97 has these four solutions. So I know that x has to equal 3 plus or minus 4 root 5. So I'm going to solve this for x to see what I get. So I can add k over to get 2 x minus 3 squared equals 97 plus k. Divide each side by 2. X minus 3 squared equals 97 plus k, all divided by 2, square root both sides. X minus 3 square root equals the square root of 97 plus k, all divided by the square root of 2, add, or plus or minus, add 3 over, and x equals 3 plus or minus the square root of 97 plus k all over the square root of 2. Would be possible for post recording an announcement for us. Yeah, sure. This one, it probably won't be up until like tomorrow or something like that, but I'll try to post this video on. Yeah. All right, so x equals 3 plus or minus the square root of 97 plus k, all divided by square root of 2. I'm gonna rationalize this, so I'll multiply both top and bottom by root 2. And get x equals 3 plus or minus the square root of 97 times 2. 194 plus 2k all over 2. And I want x equal 3 plus or minus 4 root 5, right? So I want x, what I want is for x to equal 3 plus or minus 4 root 5. So in other words, I have the 3 here. That's good. So I don't have to worry about this 3. But what I want is I want this part to equal 4 root 5. So I want the square root of 194 plus 2k divided by 2 to equal 4 root 5. And that's what I'm going to kind of go for now. So I can multiply both sides by 2. 194 plus 2k equals 8 root 5. Square both sides, get rid of the square root. I get 194 plus 2k equals 64 times 5, which is 20, 30, 320. 20, 30, yeah, 320. And 194 plus 2K. Subtract 194 over. That's 126. So 2K equals 126. And finally, K equals 63. Like the key says, this I'm hoping it does anyway. It's number 56. Yep, 63. That's how you do that one. It's kind of weird because you kind of have to work with it a lot and kind of just. I remember I was doing this problem. I kind of just went anywhere. Like I started just saying, well, if x equals 3 plus or minus 4 root 5, let me figure out what x actually equals with that quadratic that they give me. And then from there, I can kind of play around with the equation and see what I get. So this is like one of those problems where it's kind of like you start anywhere with it and you kind of go with it to see, well, what can I do after this step? So a lot of times in math, my kind of advice for people is that if you see a problem that you don't know what to do with, just start anywhere on it. And a lot of times when you start working on that problem, what you're supposed to do next kind of becomes more clear. And that's kind of what happened with this problem here when I was first doing it. I really wasn't 100% sure how to solve for K, and I'm sure there's other ways to go about it. But for me, I was like, well, if x equals 3 plus or minus 4 root 5, let me figure out what x equals. That's what I did right here. And then after that, I kind of said, well, this looks pretty similar to what I have here. The 3's match. So the second part right here, the square root of 194 plus 2K all over 2, that has to equal 4 root 5. So I can set these equal to each other, and I can solve for K, and K ends up giving me 63. So it's kind of one of those weird kind of problems to go about. I forgot who asked me about this problem. I think Anand. Does that make sense?
Yeah, thank you.
No problem. Any other questions about this problem? I didn't really get it. Let me fix. Can you explain it again, please? All right. So for number 56, and you'll see this a lot with a lot of problems in math, is that there's never really a clear-cut way to solve it, or a lot of times you'll get a problem where you don't really know like where to start or where to go or anything like that. So this is like kind of like one of those problems where I'm told that 2 times x minus 3 squared minus k equals 97, and that I know for sure that the solution to that quadratic is 3 plus or minus 4 root 5. So I know for sure x has to equal 3 plus or minus 4 root 5. And then from there, what I did is like, well, if I know that's the solutions, let me just solve for the solution with k in it. So for this part right here, I solved for x. I kind of solved it all out for x, and I got that x equals 3 plus or minus the square root of 194 plus 2k, all divided by 4, or divided by 2, sorry. After that, I kind of took this and moved it down, just kind of see it. I know that I want 3 plus or minus 4 root 5 to be my solution, right? So I know that x equals 3 plus or minus the square root of 194 plus 2k divided by 2. And I also know that x has to equal 3 plus or minus 4 root 5. So what I did is that, well, I looked at them and said, well, these two x's have to equal each other. So if they equal each other, that means the 3's match, right? The 3's were okay, that's fine. But this second part after the plus or minus were different. So I said, well, if that's the case, I know that this weird square root with the k has to equal 4 root 5. Because when they do, these x's match. So I set them equal to each other, then I just solved it all out for k. It's like one of those problems where you kind of just start anywhere with it, keep working with it until you kind of see what's supposed to happen. Does that make sense, Arjun? Perfect. Any other questions about this problem? All right, Arjun, do you have another problem for me to do? $54. Solve 15x squared plus 5x minus 70 is greater than or equal to 0. So for this one, what we want to do is when you have like inequalities of quadratic, what you want to do is you want to have the quadratic be like have the inequality have a 0 on one side, which we already have here. So it's already set up for me. And once you have the inequality with a 0 on one side, what I want to do is I want to figure out, well, what does this either factor out into, or at the same time, what what's the word? What are my x solutions that make 15x squared plus 5x minus 70 equal 0? I want to know, when does 15x squared plus 5x minus 70 equal 0? Because when I know when this equals 0, I can figure out the values where it's greater than 0 or less than 0 or anything like that. So once you figure out what is equal to 0, figuring out what is greater than it, it's pretty easy. So that's what we're gonna do first. So here, to solve this out, I can divide everything by 5 to get 3x squared plus x minus 1, 16, I think. No, it's not 16, 13. 14, 14, right? 20x, it's 14. This equals 0. So from here, we're going to see if it factors out. So I want factors of negative 42. That add up to give me 1. In this case, that's going to be 7 and negative 6. Right? Factors of 3 times negative 14. That add up to give you your middle value of 1. That's 7 and negative 6. So from here, what I'm going to do, x plus 7, x minus 6. I'm just factoring it. I'm going to factor it my own way. Y'all can factor however you want. So I factor this way. This reduces down to a 2. So this factors out to 3x plus 7, x minus 2 equals 0. So just figure out when it equals 0. You could have used the quadratic formula if you wanted to, completing the square, whatever you want. Just figure out what x values makes this equal to 0. I factored it out. This is a little easier for me. And I got 3x, it factors out to 3x plus 7 and x minus 2 all equals 0. So I set these equal to 0, and I get that x will equal negative 7 over 3, or x equals 2. Those are my x values that make the inequality equal to 0, or this quadratic equal to 0. Everyone with me so far? All right. So from here, once you have your x-intercept, what we do is I go back to this inequality, and what I'm going to do is I'm going to kind of draw a rough sketch of what this inequality looks like. So I figured out what my x-intercepts are going to be. I know that they're negative 7 over 3 and positive 2. And it's a positive quadratic, so I know that these are my x-intercepts, and my quadratic's facing up, so it's going to look something like this. So that's kind of a rough sketch of what my quadratic is going to look like. You can draw the x-axis, the y-axis here if you want to. It doesn't really matter. But the quadratic is going to look something like this. So I want to know, when am I greater than 0? Or when am I greater than or equal to the x-axis? I'm greater than or equal to this line when I'm to the right of positive 2 and to the left of negative 7 over 3. Or in other words, when I go from negative infinity, there's 2 different colors in green. When I go from negative infinity to negative 7 over 3, and when or this should be a bracket, sorry, because we're equal to 0 as well. Union 0 from 2 to infinity. Ugly parentheses, but it's supposed to be a parentheses. Does that make sense, Arjun? Perfect. Any other questions about this problem before we move on? All right, no other questions. Arjun, you have another question for me to do? No? All right. This is going to be the last tutorial, guys. No teachers allowed to get tutorials once final start. So I just got tutorials tomorrow, but not online. So this is going to be like the last tutorial for me, guys. If you have any questions, please just ask now, or you're not really going to be able to ask again. So even if it's a question that you haven't even tried yet, you're just curious about it, let me know. All right, well, I'm here till 8, so another 30 minutes. Any questions pop up, just raise your hand, unmute yourself, whatever you want. Ask me it, and we can go over it. Or send it to me in chat, whatever you want. Arjun, go ahead. Fragment 58. Okay. So Terry has an empty back lawn in the shape of a square where he wants to construct a square garden. He wants the size of the garden by 3/4 that of the sides of the lawn. When done, he would like 175 square yards of free space to remain in his back lawn. How wide will Terry need to make his garden? All right. So basically, what's happening is that there's a square. He's a square backyard, back lawn, whatever you want to call it. And he also wants to make another square garden somewhere inside of his square back lawn. And he wants the side of this garden to be 3/4 that of the yard. So if this is X, he wants the side of the garden to be 3/4 X. And when done, he will like 175 square yards of free space remaining in his back lawn. So after he makes this whole this garden, he wants there to be 175 square yards remaining after he makes that garden. Or in other words, the area of the garden or the area of the back lawn is X squared. And when I subtract the area of the small square, so I can do it in this perspective color to make it a little more clear. So this is X, that's 3/4 X. I want X squared minus, or it's supposed to be 9/16 X squared to equal 175. He said he wants exactly 175 square yards of garden land. So this is kind of what I'm going to solve here. So this X squared is the same thing as 16/16. 16/16 minus 9/16 is a 7/16. X squared has to equal 175. Multiply both sides by 16. Figure that out. 175 times 16 divided by 7 is 400. So we multiply both sides by 16/7. We get that X squared equals 400, or that X equals 200. So how wide does Terry need to make his garden? He needs to make it 3/4 of that. So 3/4 X will equal what? That's 50, 150. So he needs to make it 150 feet. So like always draw a picture, kind of piece together what's happening. And we end up getting that, well, the side of the whole thing is 400 or 200. So the side of the square has to be 150. Honestly, this problem is really weird. I don't know, it's worded kind of weird, but that's how you kind of like you're assuming a lot of things, ignoring a lot of things. Anyways, that makes sense to Arjun? Perfect. Any other questions y'all want me to do? All right, well, I'm here for another 30 minutes. Just unmute yourself or raise your hand or whatever you need to do. Yeah, 30, you said 36 multiple choice. Yeah, 36 multiple choice, 5 free response, and 2 graphic. $36 on the review. Order the following functions in order from least to greatest maximum value. Hold on. Okay, let me figure this. I have to figure out what it's really asking. Least to greatest. Oh, okay. Least to greatest maximum value. Okay. So what it's saying is to basically what it's saying is figure out what your vertex is, figure out what your HK is for each of these graphs, and once you figure out what your HK is going to be, then order them from the biggest HK to the smallest, the biggest K value to the smallest K value. So we're gonna solve each of these to put them in vertex form. So we're gonna factor them out or whatever you want to do. So we'll work f of x first. So for f of x, we're gonna factor out. Let's try -5 first. So -5, and what we're left with. No, we're gonna complete the square actually. Let's complete the square. So we're gonna isolate the first two terms: -25 x squared plus 100x plus 65, and then we'll complete the square. So factor out a -25. We have -25 x squared minus 4x divided by 2 and square it plus 4. So 4 times -25, we have 65 here. So we really added -100, so we're going to add 100 here. So when you factor this out, we have -25x minus 2 squared plus 165. So the max value here for f of x is 165. And then we're going to go on to do the same thing for g of x and h of x. So for g of x, we'll do the same thing. Isolate the first two terms and factor out the a value. So you get -8 x squared plus 8 or minus 8. Sorry. I must have went too fast. All right. Minus 8x plus 42. So divide -8 by 2, you get -4. -4 squared is positive 16. Add a 16 there. 16 times -8. 16 times 8 gives you 128. So we can add a 128 here. And then from there, get -8. That factors out to x minus 4 squared. 128 plus 42 gives you 170. So we get positive 170. That's what g of x equals. So the max for g of x is 170. Now you with me so far? Is this making sense? Perfect. All right. Now we do the last one, h of x. So for h of x, do the same thing. Factor out -1/2. So negative. We'll put h of x there. Factor out -1/2. We're left with x squared minus 40x. Divide that by 2 and square it. Get positive 400 minus 32. 400 times -1/2 is -200 plus 200. And this factors out to -1/2 x minus 20 all squared plus 168. So the max here is 168. So now we kind of just order it from least to greatest. The smallest was f of x. And then after that was g of x at 170, or sorry, h of x. And then finally, g of x is the biggest. Does that make sense? Perfect. Okay, I'm not taking the reviews. I don't think any teacher's taking the final exam review. It's really just there for you guys to study with, because this stuff is, not everyone's taking the final. So we're not gonna make people who aren't taking the final do the final exam review. So it's just for you guys to study. Are teachers physically allowed to bump 88s to 89.5s? There's no 89.5, there's no bumps like that. Teachers can bump anything they want to however they want to. Like, technically, we could bump a 70 to a 90 if we wanted to. No, I don't know any teacher that would, or any teacher that would keep their job, but they could. But that the decision's always up to the teacher. There's never going to be a policy. You'll never have anyone outside of that teacher tell him or her to bump a certain grade. Like, bumps can only legally be done by the teacher themselves. It's only decided by the teacher. So the teachers have full control of their own grade book. No one can go in and mess with it. So are we allowed to? Yeah, we can't physically bump 88s to 90s if we wanted to, but it's going to depend on the teacher, and only the teacher is going to decide if he wants to do that. Do I think the final exam is particularly difficult? I honestly, I didn't work out the whole thing. I did work out a good amount of it, so I don't want to, tell you an answer and not, it didn't work out the whole thing. But I think the best way to go about difficulty is kind of going off of like time it takes. Usually, it takes us about less than a third of the time to finish like a test or a quiz. So like we give you guys 50 minutes. It'll usually take, like, for a test, it'll take us like 50 minutes. It will, for a test, we give you guys 15 minutes to do a test. It usually takes us about 10 minutes to finish the whole test. For a quiz, we give you guys 25 minutes. It usually takes us about 8 minutes to do a test. So usually about a third of the time. And this test, I know Mr. Stevens took it. It took him about 35 minutes to finish the whole exam, which is a little less than a third. And at the same time, we took some of the problems that were a little longer and shortened them down and made it even shorter. So I think the best way to go about it is always going to be kind of how long it took us compared to how long we usually give you guys. So I don't think it's particularly difficult. If you studied well for it, to take it seriously, I think you'll do fine. And it's not long. It's not too bad. It's fair. I think the best way to say it's fair. We don't mind if you tell us an answer. You don't mind, but I'm sure the APs will mind. So I can't tell you an answer.
Is there a calculator section like on the final or no calculators?
No, we don't do calculators. Sadly, I don't even say we're, mainly me. I don't like having graphing calculators in our courses too much. 'Cause I think they just do too much. So
Yeah, okay. That's why I was that's why I wanted
sorry.
to.
If you're wondering why we don't have a calculator, I'm sure a lot of it's because of me, because I don't like having a calculator for everything.
Okay. Do you remember the question on a DLA? I don't know if you have access to it. The
don't.
two real roots question. I guessed on that one.
Two real roots. What
Yeah.
like what? You don't have to remember the equation exactly, but what did it like? Kind of what did it say?
It wasn't an equation. It gave us a table, and then it
Oh.
asked for two real roots.
Was it from the last DLA?
The DLA we took most recently.
The one we took like a week ago or something. It wasn't
Yeah.
two real roots. I think it gave you a table and it said what is a real root or real solution of the table or something like that, right?
Yeah, I don't know if you have access to it or something.
I don't, but that one, it's actually a really easy problem. It's just worded really weird. All it's really telling you is what x interval did you have an x intercept, basically. So like I can make a quick one really quickly to kind of show you. If this is x, this is f of x, and this just go, I don't know, like -7, -3, 2, 4, 7, 18. Why not? And then here we can go 24, 18, 13, 2. This is a terrible graph. This is not gonna make any sense when you look at it. -16 and -32. Why not? All right, just some random table. I have no clue what it's gonna look like or anything like that. Just some random thing I made. What it's asking when it says where is a real solution, a real root on this table, what it's asking is, well, what x intervals from what x value to what x value will give you a x-intercept. So if I
Okay.
say like, well, a is like -7 to 2, b is -3 to 4, c is 7 to 18, and d is 2 to 7. Like, what would the answer for this one be?
Give me a second. -7, 2. That's not it. B, -3, 4. That's also not it. 7, 18. Okay, so it has to be D.
Exactly. It's going to be D because from going from an x value of 2 to an x value of 7, we went through the y value of 0. You went through the x-intercept of 0. So that's
Okay.
that's what that problem was. Like I was saying, it was a pretty easy problem. It just worded kind of weird to kind of throw you off. But that's pretty much what I was saying. Well, what
Okay.
is the x interval? What interval do you have x?
And on the final exam, you guys are gonna word it correctly, right? Like you're not gonna try to throw us off.
Well, that problem, it wasn't worded wrong. It just kind of worded a little tricky to make sure you
Yeah.
understand kind of your vocabulary. You know what I mean?
Okay. Alright.
But I don't think the wording's that bad. Like anything that was kind of worded a little off, we tried to fix. We're not trying to trick you guys. So we did try to fix the wording as much as we can for the final exam. So there's no like problems that are worded so obscurely that you wouldn't, get it. Like I know on the last module, we had those kind of weird problems. It'll be like, oh, f of 3 equals f of 2, which equals 9, f of 0, which equals 0. Remember those problems? Like those
Yeah.
worded like this? You won't have anything worded like this. I think we had one, we changed it because we hated it. I don't think any of us really like those. So we changed it because this 9 f of 0 thing is kind of, it's unnecessary, right?
Okay.
Why not just say f of 3 equals f of 2, which equals 0, and 9 f of 0 equals 0,
Alright.
Yeah.
Okay, I got it.
Yeah, so we anything that's kind of worded weird like this, we also fixed. So it's not worded too bad.
Alright. Do you know when we get to see our final exam scores?
The grades are always going to depend on the teacher, but I can tell you from experience, especially, I'm sure Mr. Stevens is going to be like this because I know he has a kid and he wants to. We all want to go to vacation as soon as possible. So I know your teacher's Mr. Stevens, right?
Yeah.
Yeah, so I'm sure all of us, we all want to go on vacation as soon as possible. I'm sure
Yeah.
the final exam score will probably be up within that same day. I know for me, my students, I grade as soon as I get it, put it on online, be done with it.
Yeah, I heard
I wanna-
my friends told me you grade really fast.
Me? Yeah, I try to.
Yeah.
I try. I don't like having work on top of me, so anything I have, I can get rid of and get it out as soon as possible. But Mr. Stevens, I'm not sure how he'll do it. I'm sure it'll be somewhat similar where he'll try to get graded and done as soon as possible and in the grade book as fast as possible. So I'm sure he doesn't want to take, grading. I'm sure he doesn't want to grade final exams over the winter break.
Okay, but like, do you know when the district will allow us to see our grades? Like when our GPAs will be updated?
I know, if I remember correctly, I'm pretty sure grades are due January 6th. So when we come back, I don't know any
Okay.
teacher that actually waits that long. Well, at least anyone in the math department. I don't know anyone in the math department that'll ever wait till January 6th to submit final exam grades. I think it's just, crazy. Let me double check when they're due.
Okay, because the Module 6 test for us was graded pretty much instantly. Like, Mr. Stevens he just graded it like in 2 seconds.
Yeah, we were all like that. We want to get that test done and graded. Yeah. So report card grades are due January 3rd. So if you're talking about district itself, the strict deadline for the report card grades, which includes final exam grades, is going to be January 3rd. But I don't know any teacher that'll ever wait that long. Most will have it done before y'all go to winter break because no one wants to have any grading over their head over the break. Like I know
Okay.
me personally, I'm gonna have every single final you give me, it's gonna be graded within the hour because I want it done as soon as possible.
Okay, all right. All right. Mr. Aziz,
What's up?
are you able to guarantee that if it's not on the final review, it's not going to be on the final?
I cannot guarantee that because I haven't done the whole final exam review. I haven't done the whole final exam. To be honest, I've looked over a lot of it, but I don't want to guarantee that just because I don't know for sure. I didn't go like problem by problem and matrix on the review.
Okay, I'll ask Mr. Stevens about that.
Yeah, I think Mr. Stevens will be a better person to ask because I think he did the full exam. He probably knows it a little better, but I don't want to guarantee anything.
Okay, got it.
Sorry.
No problem.
I don't know if you have any other questions. We can still answer it, but I'm going to go ahead and start making this into a PDF so we can. I'll start making this into a PDF and put it into the chat. Of course, if you have any other questions, y'all can still ask and we'll go over it. I'll just re-export this. It's not a big deal.
The cumulative quiz we took recently,
Yes.
are the questions on the final going to be like that?
I don't think it's as hard or as tricky as the cumulative or as the cumulative.
Okay, because I thought the cumulative was kind of a joke. Like it was pretty easy for
Yeah,
me.
it's good. And if it is, I
Um,
mean, maybe you're on the right track to do well on the final then.
Yeah. The only problem was the second 6 weeks cumulative was a bit of a disaster for me.
I think it was for everyone. That was a really hard cumulative. So for a lot of people, they ended up doing kind of rough on it.
Okay, got it.
Yeah, I was not expecting any of those questions on that second 6 weeks cumulative.
Yeah, it was. It's really lucky for everyone, you guys and for us. Made me happy anyway that we had extra minor grades that 6 weeks. We were able to drop one.
Okay, wait,
Yeah.
what are the chances the lowest minor gets dropped this 6 weeks?
0%. We don't have any extra minors to drop.
Okay, and there's a certain requirement that you guys have to meet for the.
Yeah, we have to have at least 4 minor grades. So anytime we have 5, we might drop one. Not always. We don't guarantee it. We might not sometimes. But if we only have 4 minor grades, like we do this 6 weeks, there's a 0% chance we can drop any because we just can't.
Okay, and you guys just can't give us like a free participation minor?
No, we don't do that. We could, but we won't. Sorry.
Well, that'd be pretty cool.
It would be, but we don't. Sorry.
Okay.
How do you like your PDFs? Do you like them like the notes part on the side or just full page or thumbnails?
I'd go full page because I can just take my notes on the side, like on another paper.
Yeah,
Okay.
me too.
All right, so the notes thing looks that way, but if you want full page, we'll do full page.
A parabola is a thing when the x is squared, right? Not when the y is squared, or it can be both.
Parabola can be either one. A
Okay.
parabola can be when the x is squared or the y is squared. Because those can be like can be sideways or up and down, right?
Okay.
And I'll be posting this video online. It probably won't be up until like tomorrow midday or after school, but I'll be posting the video on there as well. Let me send you guys that. Also, if I set it up, so I can actually send it now.
And the only like actual formulas we need to have memorized is the D of T ones, right?
I think so. I'm not 100% sure, to be honest with you. I'm pretty sure that's all you really need to know.
Okay, all right.
How do y'all know how to upload files on Zoom?
Yeah, you see that button on the side? You see the smiley face?
No, I don't see a smiley face anymore.
If you go to the chat and then
Oh, okay.
Okay, yeah. I
click
was
the little
talking about
file
it.
icon. Yeah.
Yeah, next to the smiley face.
There's no file icon here. Did I just not? I guess I just didn't.
Wait, can you screen share it? The Zoom?
I'll send you a screenshot of what it looks like. I don't know if I'm talking about screen share.
Okay.
Okay, man, this whole thing's gonna be on the video, and I wasn't. People figuring out I don't know how to use Zoom.
Oh, you don't see it. Okay. All right.
So,
Hang
I guess
on.
I don't allow it. So
Okay, but I have the ability to send the things.
you have what?
I have the ability to send files.
Really? I don't know
Yeah,
about
but
it. But let me try if I stop sharing. Maybe it'll pop up. So I'm pretty sure So remember I went through it to make sure I can do it. This another student of mine told me that.
or you can upload it to like Google Drive or something and then give us the link.
I think I'm just gonna end up putting it on as an
Canvas?
announcement tomorrow with
Okay,
the
yeah.
video. Do you want it tonight, or are you fine doing
Um,
it tomorrow with the video and everything all together?
Whichever one is more convenient for you.
It's up to you. I mean, whatever you want. I don't have the file. Let me send it. That's annoying. Okay. I guess I was posting on the announcement tomorrow during. I'll probably try to do it during the first period because the video will be saved by then. I'll just put it on YouTube. Whenever it's done, I'll post it all on under announcements. You have the file and the video there.
Okay, got it. Thank you.
No
Appreciate
problem.
it, Mr. Aziz.
And no problem, guys.
Thank you.
No problem, guys.